And welcome back. So in this video, we're going to be taking a bit more time to get the creation of our triangles in place.
All right, this one's going to be a little bit more complicated, mostly because we're going to add some functionality that I built into the system when I was messing around with changing the grid for different LOD levels.
Mm-hmm.
Mostly, if I jump back into Photoshop, what it means is normally to calculate these triangles, I would, in this particular case, start at a center point of a square.
Hit
A
A.
square. What's up?
Hit A.
Hit A.
Yeah, thank you.
You
All right.
like that one better? Okay, so basically, I would pick a center point of a square. Not so much this square. What I'm considering a square is one that has 9 vertices in total.
The big
So
square.
yep, has a surrounded with 8 vertices. So this would be a square. So what I'm going to do is set up a loop that's going to look at all of our vertices and pick the center points of each one of these squares. And then it's going to calculate each triangle that surrounds that particular vertice. Then it's our vertex, and it's going to skip. Yeah, I know. I'm still
I wasn't
sensitive
going to
about
say
that.
anything.
But it's going to skip over to the next square, calculate those triangles, skip to the next square, and it's going to iterate through each one of these squares. Now, the system that I am going to be showing you has the ability to pick different offsets. So if I wanted to use a different step and a different offset, instead of picking this square, I could pick this square right here and then build triangles based off of a larger grid. If I were to build another layer on top of this, and for the moment hide this one out, if I were to build a larger variation, basically the second level of detail, we would be talking about the grids that would look similar to this. Just so if I turn off that, and if I turn on the lower one, you can see that they overlay. But basically what I'm doing is I'm stepping down from a higher level of detail down to a lower level of detail by just increasing my step size.
Mm-hmm.
So I could go from a step size of 2 to a step size of 4. So consider this would be a step size of 2. If I decided that I wanted a lower resolution mesh, I could set my step size to 2, or
Right.
sorry, to 4,
Okay.
and I would get this.
Okay.
Or if I were to double it again and set it to a step size of 8, what I would get would be
One big
this,
square.
one big square without these little triangles in it.
Right.
But I'm not going to draw at that level.
I think they can picture it at this point.
Yep. So, but that was the system that I had put together for dealing with multiple levels of detail, which we're not using, but I'm still going to show you how to code it in case you want to experiment with it on your own. So go ahead and kill this. Go back over here to our code and create triangles. Now, to pull this off, we're going to use 2 constants, local constants. So this will be a constant int. This will be step equals 2. So there is no step 1. You want to use step 2 as your minimum. So you start with 2. You can go from 2 to 4 to 8 to 16, etc., etc., etc. And then we're going to use const int offset, and this will be our step divided by 2. And wow, equals, I can do this. All right, so now our offset is going to be step divided by 2. Now we're going to use some nested loops. So we're going to start off with z again, and we're going to go to size minus offset. And our starting size is going to be offset. So instead of starting at 0, we're going to start at whatever our offset is. In this case, with a step of 2, we're going to start at an offset of 1. And we're going to go to size minus offset. And we're going to increment at z plus equals step. So take this whole line, duplicate it, and change this to be x, x, and x. So these are going to be the same. Now, inside of here, what we're going to do is we're going to create var index. Now this is going to keep track of which index that we're using. Right now I'm using nested loops to iterate through it, but our triangles and our more so our vertices are tracked with an index number, not an x and z position. So we need to convert our x and z into an index number. We're going to do that by taking z, multiplying it by the size, and then adding x to it. That will convert it to an index number. We're then going to take another variable called offset size, and we're going to equal or set that equal to be size times offset. This is going to work out to be how far do we need to offset our values. So when we're looking at this, if our offset is something other than 1, instead of counting every row up, we need to jump rows. So that's what our offset size is going to allow us to do. It would allow us to skip multiple rows. In this case, it would skip 2, or we could skip 4, etc., etc. So then what we're going to do with these values is, when I said we're starting with a step size of 2. So if we start with a step size of 2 and we divide it by 2, we end up with an offset of 1. We said our nested loops are going to set z and x both to 1, and that's where we're going to start. So if we look at x, which is in the horizontal, starting in 1, this is going to be this column. And if we go up an offset of 1 for z, that's going to put us at this center point. So we're going to start here. Then what we're going to do is we're going to take our offset size. Our offset size says that we're going to take our offset, which is 1, multiply it by size, which is going to be 9, and we're going to add our offset size to our index, which is starting here, which means we're going to go to 1 vertex up. Then what I'll do is subtract offset from it, which is 1, which is going to give me this point. So what we're going to do is we're going to start at this vertex and set a clockwise winding order. So we'll go from this vertex to this vertex, back down to this vertex. This will create our first triangle. Then we'll do the same thing. We'll go up here. We'll go from here to here to here. This will create this triangle. Then we'll do the same thing for this triangle, then this triangle, and this one, this one, this one, and this one, until we've created all of the triangles that surround this vertex. Then what we'll do is we'll increment our loops by 2, which means we'll increment x by 2, which will put us here. We'll repeat. We'll do the same thing all the way until we get to the end here, and then we increment z, which takes us up to the next row. And then we do the same thing row by row until we're all done. So, and then if we increased our step size, we'd basically do the same thing, but we'd be doing it with these points. So if we had a step size of 4, our offset would be 2, so our starting point would be here, and then we'd start here, then we'd skip 2, go here, or skip 4, so 1, 2, 3, 4, we go to this point. Then we'd increment up 4 more, 1, 2, 3, 4, go to this point, and then increment 4 over, and we do this last point. So that's what our step size and offsets are going to allow us to do. So we can work with multiple level of details. The trick with it is if you're going to play with the level of details, your sizes have to be a power of 2 plus 1, which means you have to have something like 5, 9, 17, 33, 65, etc. to make the LOD stuff calculations work out correctly. So if I jump back into code, let's go ahead and create that first triangle that I was talking about. To do that, we'll say base triangles dot add. To it, we're going to add our index. That's going to give us that center point, plus our offset size. That's going to give us the point directly above our index. Then we're going to subtract offset, which is 1, which is going to give us the vertex directly to the left. So go ahead, duplicate this line, and then instead of subtracting offset from it, we'll just add offset size. And then we'll take our base triangle and we'll add just the index to it. So that will give us the index. And what you'll find is every single one of these triangles is going to end at our index. So if I take these 3 lines, and if you remember from our diagram, each center vertex is surrounded by 8 triangles. So we're going to need 8 of these. So go ahead, jump back over here. That's the first one. That's 2, 3, 4, 5, 6, 7, and 8. So our second one is going to start at offset size. Then we need to add offset to it. That will give us the one to the right, and then we end back on index. We're then going to start at offset size plus offset. We'll go to plus offset, that, and then back to index. That will give us this triangle. Then we're going to do each one in order going clockwise. So go back. So offset, from there we'll go to offset to minus offset, size plus offset, back down to index. Then from there we'll do minus offset size plus offset. Now there's another pattern that you can pick up, is that the second one in each one is what we're using for the first one of the next one. So I can take this second one here, and that will be what we use for the first one here. So that one will give us negative offset, which means this one will be negative offset. And then we go to negative offset minus offset. Minus negative offset to
Nice.
What? Oh,
You just keep you keep calling offset size offset.
oh yeah. I
And then
just
of
keep
course
saying
you call offset offset. So I was like, whoa, lots of offsets here.
yeah. Sorry, my bad. They all blur together.
Yeah, I know.
And then we end up where we started, which is plus offset size minus offset. So that wraps us all the way around. And then I can close that off. And that is the code that is needed for creating triangles. Though we can't test it quite yet until we've implemented the next couple of methods, which is going to be our instance constructor and our update method. So we're going to have to put those together before we can actually see whether or not these triangles work.
Okay. Awesome. Well, with that, that is going to conclude this video. Thanks a lot, everyone.